Good morning, students. I hope you all are fine with your family members. I'm Sapna, your chemistry teacher. In this period of lockdown, our school has decided to conduct online classes via YouTube so that you don't face any losses in your studies. In our course, we are going to cover first term syllabus of chemistry. In our first term, matter, physical and chemical changes, and water chapter, we will go through these three chapters. At the end of each chapter, I will give you some question for revision. Today, we will start with first chapter of our first term, that is matter. Matter. First, what is matter? We know any object has mass and occupy space. That object is known as matter. Any object has mass and occupy space is known as matter. This thing we know very well, known as matter. Matter occur in three states. States of matter. Which three states it exists? Solid, liquid, and gas. Solid, liquid, and gas. Three states of matter. Now, these solid, liquid, and gases, these matter are made up of molecules. These are made up of molecules. We know tiny particle, that is known as atom, which is the basic unit of matter. When atoms combine together, it forms molecules. Molecules are arranged differently in three states. Which three states? Solid, liquid, and gas. Due to molecules arrangement, these three states occur. Molecules, they are held together by a force. Molecules held together by a force, and we call this force as intermolecular force. What we call it as? Intermolecular force. This force, it held together two molecules. There is space between two molecules also. That space between two molecules, we call it as intermolecular space. We call it as intermolecular space. These two terms are clear? Intermolecular force, intermolecular space. Intermolecular force, force which held together two molecules. Force held together two molecules. Then what is intermolecular space? Space between two molecules. Space between two molecules are called intermolecular space. Force of attraction and space between molecule. Force of attraction and space between molecules. It is differ from substance to substance. Now see toward the book. Take your chemistry book with you. We start with this chapter, matter. Already I explained what is matter. That any object has mass and occupies space, we call it matter. Now, same thing in the book they have written. Another, matter is made up of tiny particles. That tiny particles we call molecules. So underline first line. Matter is made up of tiny particles called molecules. We know molecules are made up of atoms. Another thing, molecules are held together by a force of attraction. Underline, molecules are held together by a force of attraction. We call intermolecular force. That force we call intermolecular force. These molecules also have space between the particles. Molecules also has space between them. We call it intermolecular space. So underline both terms, intermolecular force and intermolecular space. These two terms are more important while discussing about matter. We all know about the states of matter: solid, liquid and gas. Now see this diagram. They specify the term force here with the red arrow and space. Now force means the force of attraction. It attracts molecules toward each other. Space means there is a gap between two molecules or two particles. Now, these two properties, force of attraction and space between the particles, force of attraction and space between the particles, it differ from substance to substance. These two properties are differ from substance to substance. Now two important points they have given. See the first one. Stronger the intermolecular force. Which one is stronger? Stronger the intermolecular force, the smaller is the intermolecular space. Stronger the intermolecular force, smaller is the intermolecular space. Second, the weaker the intermolecular force, weaker intermolecular force, larger intermolecular space. Now you notice when one property like force, it is stronger, then another property, that is intermolecular space, it is smaller. Then if intermolecular force weaker, intermolecular space larger. See these diagram given in the book. This one, molecular rearrangement in solid. So we can see the molecules are tightly packed. It means intermolecular force is stronger. There is no visibility of space. Smaller is the intermolecular space. Second diagram, liquid. Weaker intermolecular force, stronger intermolecular space. Third one, gas. More space, larger intermolecular space, weaker intermolecular force. Weaker intermolecular force. These two properties differ in these three states: solid, liquid and gas. Same thing you have read in this book. Force of attraction and also the space between the particles differ from substance to substance. Through the diagram it is clear that these are differ from substance to substance. You know about the states of matter already in the starting. I have written on the board states of matter. 3 states are there. Diagram also you have seen. Solid, liquid and gas. Solid, liquid and gas. Now I will show you. This one is solid. Okay. This one is liquid. And third one is gas. Third one. So these are the 3 states of matter which exist in nature: solid, liquid and gas. The 3 states of matter: solid, liquid and gas. Solid, liquid and gas. They have given the example of solid, ice, liquid, water and gas, water, vapor form. That water exists in 3 states: ice, water and water vapor. These are the 3 states. Water exists in 3 states: solid, liquid and gas. Ice, water and water vapor. So water exists in 3 forms. See first one, ice it is. This one is ice, solid form of water. But it is solid form of water. Then second one, it is liquid form, liquid state of water. And third, you are able to see steam coming out from this nozzle. That steam means water vapor. It is the gaseous state of water. Which state? Gaseous state of water. Ice, water and steam. That steam, it is a vapor state, mean gaseous state of water. See in the book, which example they have given of 3 states? Water. Water exists in 3 states: ice, solid, water, liquid, water vapor, gaseous. We can understand that kinds of matter, that is the molecule constituting ice, water or water vapor, is the same. 2 atoms of hydrogen and 1 atom of oxygen combine to form 1 molecule of water. H2O. 2 atoms of hydrogen, 1 atom of oxygen. When these 2 combine, they form 1 molecule of water. The formula of water is same in solid state, in liquid state and in gaseous state. Next, what causes the difference in state? Molecules making up the substance do not change in the 3 states. Mean molecules remain the same. Then why it is that the substance exists in 3 states? Now this one is a question. Why is it that the substance exists in 3 states? It is in fact the force and the space between the molecule that determine the states of matter. Which 2 points once again they use? The force and space between the molecules that determine the state of matter. Now see the first point. Intermolecular force is stronger in solid state. In this diagram I explain. Same thing. Intermolecular force is the strongest in solid state, weaker in liquid state and weakest in the gaseous state. Stronger in solid state, weaker in liquid state, weakest in the gaseous state. Second point related to space. And so the intermolecular space is the smallest in solid state, larger in the liquid state and largest in the gaseous state. When we draw molecular arrangement structure in 3 cases, in case of solid, molecules are tightly packed. Molecules are tightly packed. In case of liquid, arrangement of molecules are loosely held in liquid. And in case of gas, molecules are independent. They are free to move anywhere in all direction. Next is interconversion of states of matter. Interconversion means solid change into liquid, liquid once again change in form of solid, liquid change in gaseous state, gaseous state. On cooling, again change in form of liquid. That is known as interconversion. Solid change into liquid, liquid change into gases. When gases cool down, once again it turn in form of liquid, and liquid on cooling again change in form of solid state. And these things we know. On heating, ice turns into water, and we know very well, and water into steam. When we heat ice, it turns in form of water. When we continue heating, then water change in form of steam. On cooling, steam turns into water and water into ice. Now such change in state about other substances too without change in the composition, means there is no change in the composition of molecules present in that state. It remains same, means H2O. It is same formula for solid, liquid and gaseous state of solid. When change in form of liquid, liquid change in form of gas, then reversible conditions are there. We call it interconversion of state of matter. What we call it? Interconversion of states of matter. Next they have given about temperature. Constant temperature at which solid turn into corresponding liquid. At constant temperature, when solid turn into corresponding liquid, is called melting point of the solid. Underline this line. Is called melting point of the solid. Constant temperature at which a liquid freezes, that is, turns into the corresponding solid, is called the freezing point of the liquid. Underline this also. Melting point. Second one, freezing point. We know freezing point of liquid is same as the melting point of the corresponding liquid. Freezing and melting point is the same of a liquid of the corresponding solid. Example they have given: water freezes as well as ice melt at 0 degree Celsius. It means melting point and freezing point of ice or water is same. The constant temperature at which a liquid boils is called the boiling point. Liquid boils is called the boiling point of the liquid. And what is the boiling point of water? 100 degree Celsius. What is the melting point of water? 0 degree Celsius. What is the freezing point of water? 0 degree Celsius. Boiling point 100 degree Celsius. And this temperature at which steam will condense. At the same temperature, steam will condense. Interconversion means when one state of matter change in form of another, means solids change in form of liquid, liquid change in form of gas, solid change in form of liquid, liquid change in form of gas. Once again, when we cool it, it change in form of liquid. In gas, change in form of liquid. Liquid, change in form of solid. Name of the process we know. When solid change in form of liquid, we call it as melting. What we call it as? Melting. When liquid change in form of gas, we call it as evaporation. When gas change in form of liquid, we call it as condensation. When liquid change in form of solid, we call it as freezing. So these terms we use for the interconversion of solid to liquid, liquid to gas. How many terms we use? Solid when change in form of liquid, melting. When liquid change in form of gas, evaporation. When gas change in form of liquid, condensation. When liquid change in form of solid, freezing. This one is the interconversion of the state. What is the melting point of water? 0 degree Celsius. What is the freezing point of water? 0 degree Celsius. What is the boiling point of water? 100 degree Celsius. We will discuss up to this in this video. Now the kinetic theory of matter. In next video we will discuss. Students, you have to revise full chapter. Important terms, the definition, diagrams given in your book. You have to practice. Interconversion state of matter. You have to read full. Learn given definition in these passages. Then we will start, after revising the previous one, with kinetic theory of matter in next video. Thank you.